Okay, going live. How's everybody doing? Okay, I still see more students logging in here, but I think we'll go ahead and get started and get this going. You can't hear me too well. Okay, see what we can do about that. All right, is any better? Oh, good. All right, so we'll pick up then from where we left off on Monday. And we were talking about generating these unique labels as part of our macros. And go by control. Oh, yes, changed my pointer. I'm going to remember that sooner or later here. Now you can see that. Get this out of the way so I can see that. Okay. All right. So here's the code that has that example, and we're looking at read buffer here, and you can see right at the top, read buffer is where we're creating this macro with the 3 parameters, and we're going to do these clear register instructions and do this work, and then we're using those symbols loop and exit that we saw in the previous example here. And we said that the first time we would invoke any of these conditional unique label generation tools, then we will start with AA and then increment AB the second time and AC the third time and so on. And then we can also do this little gate trick here, if you will, where we're doing the tick and in device tick, where we could actually append or prepend depending upon what you want to put in here. And that's where we generate this XF1, XF1. So the example code here then, where we did that, we created the macro read buffer with these 3 parameters. And then the first symbol that we had is loop, and it's $loop here, which means it's going to get replaced when the macro processor runs and does the replacement for using this macro here, read buffer. And likewise, exit, when we go to use it, it will also get substituted and a new unique name for that. And this is the result. So here, $loop got changed to $AA loop, and $exit got changed to $AA exit. And then, of course, we don't need the macro define and macro end. Those get stripped off by the macro processor. And then we have the code in between. But also, we had the test device at loop, and we had the read, and we substituted that in device with whatever was passed, what we called this loop. So we had uh, parameter F1 and F1. Now, the other thing that's interesting too is that when we have this tool, this macro processor creating these symbols, we want to be able to use the symbols. And that's what we saw here, where we had defined the $loop in this line here. And so the macro processor now has to create that unique label that it created, that $AA loop. And so it replaces that with AA loop. And then we'll do the same thing with exit, jump if equal, instead of $exit, it's now $AA exit, because that's the actual symbol that's generated for this instantiation of this macro. Now I put up here in blue is that somewhere in our code, we actually called right here at this line here, we actually called the macro read buffer, which is then past these 3 parameters. That's how we got that F1. And the same thing with buffer and length. We use buffer here, but if we come up here, we can see that, oh yeah, we had the and buff address, which was that second parameter. And then down here, the and REC length, record length, so that it was then substitute with length and length, buffer and buffer. Okay, is that any questions? Okay, then let's get on to some more fun stuff. One additional thing we can do with our macro processors is we can use conditional expansion, conditional logic for doing expansion. And this is where we actually left off, but I wanted to summarize that previous slide because I had a couple questions. So that's good. So now we're going to talk about using conditional logic in our macro expansions. First example we're going to take a look at is using if, else, and end if. So just like you're familiar with using if, else, and end um, in your what other programming languages you use in logic tests, and you were always using logic tests, it's going to work very similar here. Now we do have to define the end if in this macro processor. It needs to be very specific. This is when the last statement appears for this conditional test. Okay, so during the macro time variables, any symbol that begins with character and is not a macro parameter can be used. Now, macro time variables, we probably didn't mention this before, but if they're not set, then they will be default set to 0. We'll initialize them to 0 if the programmer does not specify a value for them. And then you can change them using this set directive right here. And we're going to see that in the next line here where we had this EORCK variable, and we're going to set it to 1. Okay, so that's just what we're going to do. We'll use that directive set and give it a value. Okay, so if, else, end if, and set are the 4 new directives that we're introducing now, and we're going to talk about these in this code example to give us a better idea of how they work and why we might use them. Okay, so in this example here, we're going to take read buffer and we're going to build it into a macro. Okay, so read buffer, define macro with these 5 variables. And if you look down here, you see that the macro end, the M end, is down here at the very end of read buffer. Everything else is part of the macro. So we have the 5 parameters we can pass. And now we're going to do the if. And we're going to say if EOR, that's this one here, is not equal to null, then we're going to use the symbol EORCK and set to 1. End if. That one's a pretty simple one. So here we're doing a conditional test on the value of EOR, whatever's passed as VOR, and we'll set it to 1 if it's null. Okay, then we're finishing up our macro here, clear X, clear A, and now we got another if test. So yes, we can do if, end if. So now we're going to test on EORCK equal to 1. Oh, EORCK is this variable that we just created here. All right, so if it's equal to 1, well, the first time it's going to be equal to 1, right? Then we're going to call load char with that parameter EOR. Okay, and then RMO and then end if. Then we do another if, end if test, looking at a different parameter. Now we're looking at max length, and we got the end if. And then, and remember, we're using symbols in here just like we used before, so those are all going to behave the same. Now we have an if, end if here. Now checking for EORCK equal to 1. And then we break out of this with the mend. So when we go to call read buffer, then it's going to perform this work, but all of the actual testing is going to be removed because that's just instructions to the macro processors. So it's not going to generate any code to be used at runtime, to execute at runtime. So it's going to do that work and strip those things, and then we'll just end up with the resulting code if it passes the logical test. And that's one of the things we want to do too, is we don't want code in here if it's not a value that we want, that we're looking for. In this case, EORCK equal to 1. If it was some other value, don't generate these lines of instructions. Okay, so that's how we can get more that's how we can get better code by removing dead code or unessential code using this conditional logic, which is always a good thing to do. You don't like to have extra code just hanging around that can generate errors or get executed by accident because of bad testing or whatever. bad jump instructions. Lots of different things can happen. So you're removing potential errors by not including instructions that are not needed. And that's why we want to do these conditional tests. All right, so let's look at the generated code. So in this example here, first off, my apologies, those should be commas, not periods. There's our 5 parameters that we're calling when we call the macro read buffer. Read buffer with F3, buff, RECL, 04, and 2048. Okay, so you saw that if test, right? And we saw the set. Well, we're not doing that because we're going to go ahead and generate that code because we set it to 1, then we tested it, and yeah, it's equal to 1, right? So if this is not equal to that, we did the set for this symbol here and endif. So now we're doing the X and the A, and then here's our first substitution, right? If EORCK is equal to 1, what is EORCK equal to? Oops, EORCK, we just set it to 1, right? So it's going to be set to 1 the first time. Then we're going to do the load char with this parameter right here, EOR. And so that's where we got the 04 from. And so we'll just place it right here, do the RMO. And then I think that's where we had the indif. Yes, right there's the indif. And then we immediately went to another if test. If max length is equal to null, max length is right here. And we can see that in this example, it's not null, it's 2048. Okay, so if it's equal to null, then got myself off on a different path here. So in this case here, it has a value. All right, so we are going to take that value, max length. We're not going to do this. We'll skip over this. So if it's null, which it's not, then we would just do this LDT format 4 instruction and set it to that hard-coded value here, but it's not. So we jump down to the else conditional test, and we're going to use an LDT format 4 instruction, but now we're going to use max length here and put that value 2048 into the code. Oops, what too far ahead there. There we go. What happened to my... I had a slide which disappeared on me. Okay. All right, so that's what we're going to do. There we go, 2048. So now it's going to, there's a 2048 immediate value right here, format 4 instruction. And then we just continue doing the same for the rest of this code. We have the indif for that conditional logic here. And then, I'm sorry, right here where we were. And then we do the test device. Now here we're doing the jump of equal loop. We already saw these symbols, but as you can see here, jump of equal now to up here, sorry, jump of equal now to AA loop. AA loop got replaced there. So the rest of that's going to perform the same way as what we saw with the label replacement earlier. All right, then we just had this one additional if test down here. EORCK is equal to 1. Now this time we're like we did up here, testing it for equal to 1. And we set it, let's see, EORCK, we set it to 1. We haven't changed that value, so it should still be 1. And we would then do the compare register, ANS like we did here, jump of equal now to AA exit, which we had replaced. All right, then we go down, we had this additional, so we did that if test, and then we just have the macro end, and that's the instructions that would still be generated. And that's the resulting code based upon calling read buffer with these 4 parameters. Okay. Now let's take a look at a little different case. Let's talk about what happens when we call read buffer, but now we use the null value here for EORCK, EOR rather. So in this case, oops. So in this case, the first if test, which says if EOR is not equal to null, that's where we did this set one. Well, in the second example, it was null. So it's not. So this test is not true. So we skip over that. If EORCK, well, we didn't generate it, right? If max length is null, it's not. Okay, so here we are. We've passed the first if test. We generated the clear X, clear A. And then we came down to this if test that we were just looking at, where it was no longer null, but instead of 2048, it now has 80, much smaller number. So that's the number that we generated here for this parameter. Not generating all these instructions because didn't pass this test. Okay, and then the only other place we checked for EOR was actually EORCK was down here when we did this compare register A and S. So we no longer need to generate those codes, those instructions, because it is no longer true. Now, look at the other interesting thing that happened as well. Going back to our prior discussion about generating unique labels, is that this is the second time we called read buffer. And so now you'll notice that these symbol names have unique names. We've incremented it from AA loop now to AB loop. And so we're calling AB loop in there. And we called, instead of AA exit, it's now AB exit, right? And so we didn't actually call it because that test was no longer true. But you can see that the parameters got changed both where we were using them as well as where we defined them. In this case, the macro defined them for us, and they're unique. It's no longer AA, it's AB. Okay, and it turns out there's one other case that's interesting as well. So let's call read buffer again. But this time, we're only passing it 4 parameters. We didn't pass it that 5th parameter. Okay, so if you were wondering, would this generate an error? The answer is no. We're allowed to do that. And it's going to be very similar to what we saw here. The only difference is that if we had just moved this 80 to this position here and didn't include the 5th parameter, then this would be interpreted though as that 4th parameter, not the 5th parameter. So we need to have, if it's somewhere inside of this list of symbols that we created here as parameters, we would have to actually put a null value between the commas rather, to indicate that that position is null. It's not provided. Okay, but if it's the last one, we can just simply leave it off. Now, as you are probably thinking about, we have other ways of using these parameters, right? We can define them, we can use them by name or by their position. We don't have to necessarily just read a comma separated list. But we chose to do it this way because that demonstrates that you can, in fact, do this with the macro processor. And like we're doing with a lot of capabilities inside of our assembly level code, is we're not doing a whole lot of error checking. We are doing some error checking. We're just not doing a lot of it because we want the programmer to be in control at a systems level, which means you must be very deliberate and very careful about what you're building and testing that you're doing to make sure it is working correctly, because you're not relying upon the assemblers to do a lot of that work that we do at the higher level. At the system level, we need to have that flexibility to do things that we know is right and not have the assembler do error checking for us. So there are some basic fundamental things that'll check for us, but there's a lot of things we can just get away with and get into trouble with if we're not careful. So you have to be careful when you're working at the systems level. Okay, so in this case here, we had max length. We're not, the programmer decided, I'm not going to do that test here. It's just always going to be null. So this case here, right, is going to say, oh, it's really null because it was not provided in this last example here. So we would expect this line of code to get generated and not this line of code. And I think that's the only place we use max length. So let's see what we actually did. Well, we actually provided our length. So we provided F1. So here we can see the substitution for F1. And coming down now though, where we had this value here was not provided, right? So instead of comma null, it's just not left there. So the test will still provide a null because there wasn't a parameter value provided there. So it did not take this value that doesn't exist here, but it did do the else side, which says, I'll take our default, which is the maximum length, which is this 4096, and use that instead. Okay. Oops, got ahead of myself there. All right, any questions? This conditionals with if, else, and if, along with the set. Okay, that sounds good. Then let's talk about the while and end while. Okay, so we can use that kind of logic as well. And that's what we're going to look at next. Nope, I took that out because it was pretty simple. The thing that to remember about the while and end while is that um, you can provide a number of items that you are testing on in your argument list to the while loop. And when you're doing that, then what you're going to do is you're going to, the macro processor rather, is going to actually track the number of arguments in the list. And so it's introducing this in items in order for it to keep track of that. And that way, if you want to do your testing by positional value, you can simply do some testing to make sure that you've got all the parameters. Like if you want to pass it 5 parameters and test on them or use them as replacements, then knowing how many is actually in the list is useful, because then you can simply, do a while 1 through n items, for example, and then loop on that, and you can decrement end items and or increment it, whatever you want to do, so you can use that parameter for testing, and the macro processor will automatically provide that for you. Okay, so that's an important thing to know about the while loop, because it's typically one of the things that we like to use the while loops for, is working through an array or a list. Okay, nested macro invocations. So we talked about pass 1 and pass 2. We looked at an example of nested macros, but from the macro processor perspective, if you're building a macro processor, there's a couple of additional things that you need to be concerned with and build into it. One is that the macro, of course, processor is going to get invoked multiple times in the case of macros within macros. And therefore, when we're expanding it, we're going to need to basically maintain state as we're going down deeper a level, and then we're coming back up to the 0 level. Okay, so the problems we get into, of course, is macros are replacing symbol names. And so we have to be concerned with making sure that we're using unique symbol names when we're doing these nested macro expansions. Okay, so the arg tab is going to be an important tool that we're going to use to keep track of the arguments that are unique to that particular expansion invocations expansion. We saw that we saw how that would work from a couple of different perspectives on last lecture. And then we're going to need to worry about when we're actually in a state of expanding. Okay, so to do that, what we'll do is we're going to build a build a stack. When I say we, those of us writing macros will need to build a stack for the macro processor to use, and then use a while loop to put these arguments onto the stack or pop them back off so that you're now working with the correct symbols for that particular level that you are in. Okay, and hopefully it doesn't sound too tough, because it really isn't. Really talking about, you know, using the same structures that we used before: the define tab, the name tab, and the arg tab, right? And what we're going to do is we're still going to call process line and get line. Okay, so macro definition, we'll start off here saying, we're going to do a define. Can't expand a macro unless we've actually defined one first. So we'll do a define. We'll call get line for us to be able to define this. And then at some point, we are going to then do a macro expansion. And so we'll call process line. And process line will then say, oh, it's just another define. Okay, call get line, that's okay. Or if we're doing a macro expansion, then we'll go into expand, and we'll push the arguments if we're currently in a macro. If we're currently in a macro definition or expansion, we'll go ahead and put those arguments into the arg tab called process line, so we can either define or expand again at the appropriate level. And then once we complete, process line will then call expand back, popping those symbols off the arg tab so that we can continue the expansion. Okay, so let's look at this now from a one-pass macro processor, because we talked about the one-pass, two-pass issues previously. Okay, so let's look at it this way now. The macro processor is running and initially expanding will be set to false because we have to define one first, right? So it's just going to keep calling get line process line to do define or expand, right? So if we get down here and we call process line, then we're either going to define, in which case we'll call get line, or we're going to expand. Now, if we do call expand, we want to take that symbol expanding now, we want to set it to true. Then we can call get line process line, and then go back to process line, because we're either going to define now, which would call get line, or we're going to process that line and do some more expansions at that level. Once we have completed that work, we come back here, and the macro processor can simply call get line to get the rest of the code. However, if it encounters another macro, it's going to test that macro to see if it's currently being expanded. If it's not, then we're good. Read from the input, process that macro definition. If it's true, then we need to read the symbols from the define tab and then start. Let me pull up a couple more. I should have just put the whole screen on here. Start doing the expansion. All right, so now it's a little bit trickier because we've gone to level 1. We start off at level 0. We've gone to level 1, but we haven't talked about how to track that yet. And so we need to modify our current diagram to give us that level of detail so we can account for that. So we'll do is we'll use this nomenclature here. Macro processor runs. Initially, it's going to be at level 0. And at level 0, we're not expanding. We've not defined. We're just calling get line and get line and get line, doing regular code work until we invoke the macros, right? We have either a define or an expand. First time we have to have a define. So we'll call process line. Process line is a function. Okay, and if we're defining the the macro, that's good. We'll just pass it pass it the function that we're defining. It will call get line and it will define it. Then it returns. However, if we're calling process line because we want to do a macro expansion, we will call the expand function, and then it will call get line and process line depending upon what it needs to do. And now notice we've increased the levels. We've gone another level because we've already gone one level here. And so what we're going to do is we're going to call get line, but at level 1 now instead of level 0, or process line at level 1 instead of level 0. Okay, so get line will go here, do the work. But if we're doing another expansion, then we just simply loop through here and we increase the levels, recognizing that we still need to do the work that we talked about here, but now doing so at the appropriate level. So we're putting those symbols onto the arg tab list. Oops, go back here. Okay, so putting the arguments on the arg tab list and then pulling them off as we do the expansion, as we return from the expansion, that is. Okay, and then once we do all that, we come back to level 0 here, and we can call get line, and we got to test, are we still in the middle of defining a function? Yes, then we need to read from the def tab, else we would read from input directly, get line. All right, so now we're getting to the point where you can start summing up some of these things that we've been talking about in the macro chapter. One of the advantages is that we saw a 1-pass, we saw a 2-pass, and it turned out that the 2-pass was actually more work, which kind of made sense, but it also meant that we could do nested macros, which we liked, right? So that's an advantage. We can reduce our macro assembler to a single pass macro assembler, and we actually get more capability with it, and that's a good thing. The other thing, though, is that we also can share data structures. So as we're building our symbols, we're going to track them depending on what level we're in. So as we're doing the expansions, we'll still create unique symbol names, and then we can go back up to the higher level macro and still create unique symbol names, which means that we can reference those symbols in other sections of the code. So those are all advantages. Disadvantage, however, is yes, it is more complex because we had to do some additional work to manage the nesting and the 1-pass. And we also restricted ourselves, as you probably recall, to saying that we had to define a macro before we could ever expand it, which I don't think is a disadvantage. That's just something that we need to remember because it's different than our actual assembly code programming that we saw in the main part of the chapter 2 and 3. All right, so let's look at it from a different perspective. All right, so pass 1. Okay, first thing we need to do is we need to read a line of code, right? And then when we read a line of code, what we need to do is we need to search the op tab, or what we're referring to as a pseudo op tab. And notice we have these points here R that we can jump around. So that's a way for us to be able to call R from different locations without drawing arrows all over this diagram and making it messy. Okay, so we'll reference R here. We're defining R as the entrance here. Okay, so read, search the op table. Okay, if it's in the op table, then what's its type? Is it a macro or is it an op? And if it's not in the op table, then we're going to go to the name table, the macro name table. Is it in there? That means it's defined. So we wanted to do it. We're doing an expansion. And then we come back and repeat. But if it's not in the name table, Then we're going to go to the machine op table. Okay, so that's the actual opcode table you've been working with and still are for assignment 2. Insert the op table and you would process that machine instruction. You're outside of the macro at this point, and then you go and get the next function to translate. Okay, so if it's a macro, we talked about it was in the table and it was defined. Okay, we're doing that work, come back. But it could be a macro expansion, in which case we have to process the expansion and then we go back and get the next function. Now we do have this line here saying type if it's not a macro define, and if it's not a macro expand, then go to pass 2. But we said we don't like pass 2. We like a single pass macro processor. So we will remove that block and just not do a 2-level, 2-pass macro expansion processor. And we'll be happier for that because it'll be easier to I think, to develop and test. Yes, the screen is black because that was my last slide for this chapter. I can put it back so you can see something besides black. Okay, so that's what I wanted to talk about and introduce to you and go over with you that I prepared for discussions for this chapter. Does anybody have any questions? Best way to study. So yes, I will be posting, as I mentioned in the chat session earlier, that the study guide will be posted for these 2 chapters here, 3 and 4, on Friday. And I will have also some instructions about the test format itself. And so I'll have some instructions about that to help you prepare, so that what you should be doing is, yes, you have the chapters, we've walked through the material, you'll then have some study material to help you focus on some specific problems, recognizing that all of chapters 3 and 4 is testable, but there are some parts that I'm going to emphasize more than others. So that's the purpose of that. So what I would encourage you to do is to actually walk through each of those figures in the book and see if you can do the expansions yourself. See if you can. I know you've seen them, and there's not a whole lot of other examples to work from. I'm going to look for a couple that I can post for you. I think I have a couple that I have from some prior semesters. I'll put up there as well. But that's really the most important thing that you can do, is walking through there and seeing if you can do the expansions and get the same results that the book gets or that my examples get for you. Okay, that'll help you, as well as the terms. You need to understand the terms, and you need to be able to, of course, problem solve, which in this case is writing code and doing expansions and defines. Now, if you would like to study with a partner in this social distancing time that we're in, there are a variety of chat tools that are available to you. Zoom is also available to you as well. There's some student resources. I believe you received some emails from the university with some student IT resources that are available to you that you can use to help you do some collaboration online. I'll also go ahead and open up in Blackboard a discussion table, probably a blog. I'll either do a discussion group or a blog. I'm not sure which yet. Maybe I'll do both, and you can, use what works best for you, and I can learn from you. So these tools are available, and I strongly encourage you to use them and just check them periodically, or you can turn alerts on and check out the email, again, the tools on the email that the university sent out about tools that are available from the IT store here at State. Yes, I will be answering emails during the break. My day job doesn't have a break, so that gives me time to do that. As far as the specific time, yes, the exam will start promptly at 5:30 p.m. on Wednesday, and it will be timed. So I'll do that. Decisions on the exam scores for the first exam. Actually, yes, I have. There's uh, there were some issues that the grading assistant had with two of the problems because there was the dependency on one problem based upon how you answered the previous problem, and she didn't take that into account. So I'm redoing those two particular problems, and then I'll post those scores, and I will actually upload. I'll scan all the exams and I'll upload them in the Blackboard so you can get those. So everybody's scores should be going up. I when I was going through them and looking at them, and I noticed that almost all of them had some issue because of dependency. So the score values will be going up, and then I'll get those to you. Do nested macros normally go further than one or two levels in production code? Nah, not really. They typically we typically don't like to do nested macros too much. The problem with them is that they get pretty complex pretty quickly, and when we're writing an assembly code, it's very lengthy, as you might imagine. You know, even though we want to write smaller functions at the assembly level, the fact that we're writing in assembly instructions where it's going to take 3 or 4 to do something that you could do with a single line of high level code, or something like a Python or Java where it might take more like 10 machine instructions for a single line of that code, it gets rather lengthy. And so when you start doing the nested macros in real code, it really starts doing lengthy expansions, and that gets really hard to debug. So we typically don't go too deep. Exam 2, mostly new material. It's going to be the 2 chapters that we just covered, 3 and 4. And as I mentioned before, and I think I understand the question better now that I think about it, is that it's mostly new in the sense I'm focused on the concepts that we were talking about, particularly in chapter 3, the new things that we introduced in that chapter, but it's still building upon what you know about the machine, the architecture, and the machine instructions and addressing modes that you learned in chapter 2. So it's building on that, and I'm focused on that, but you still have to be able to work in the 6 family languages. And yes, the test will be timed. We'll start 5:30 promptly on Wednesday, and then we'll have that scheduled for 1 hour and 15 minutes. Yes. And the question that didn't come up, but you're welcome. The question didn't come up, but what we'll be doing on Monday is I'll open this up live, and this will be this time on Monday, 5:30 to 6:45 will be available to you to have basically as an open study session, question and answers. I'll be on, you'll be on, and we'll just stay live as long as people have questions, and we can help you through whatever you're still struggling with in preparation for the exam. I want everybody to do well on exam 2 here. I'm feeling confident. I think we've been getting a lot of good questions, even in these sessions here. We've been getting a lot of good questions, so I'm hopeful. I don't have an answer for you yet now on on that level of format. I'm still working through a couple of things on as to which tool. I'm down to 2 tools that I'm looking at using, so I'm not really sure how to answer that just yet, but I will have that answer for you on Friday. So people are asking about the specific date of the exam. Going back to the syllabus, you can see it's Wednesday, 8 April. We're off next week, of course, because that is still spring break. So we'll have, like I mentioned earlier here, Monday the 6th will be basically a open study hall, and then we'll have the exam on Wednesday, covering chapters 3 and 4. Okay, I see some people are dropping off, so I hope everybody has a restful and safe week off next week and take advantage of the time to study. I know that we are still participating in stay at home, and so that should be helpful for getting some time to study and stay connected with each other as well, and still keep checking with Blackboard, and we'll get those forums up. Okay, well, thank you and be safe.